Hello everyone, I'm Singbe Park, a philosopher of science at UNIST, Ulsan National Institute of Science and Technology. In this video, I briefly summarize Chapter 10 of my book, Embracing Scientific Realism. The target viewers of this video are the philosophers of science who have already published and aim to publish more on scientific realism. Let me first introduce the topic of this chapter. Does the scientific realism debate matter for science? Does the scientific realism debate make any difference to scientific practice? Does scientific realism have positive or negative implications for scientific practice? How about scientific antirealism? What can scientific realists and anti-realists do to contribute to science? This chapter answers these questions. There are two prominent arguments in the realism debate these days, the pessimistic induction and the selective induction. The pessimistic induction holds that since past theories were discarded, present theories will also be discarded. The selective induction holds that since some theoretical assumptions of past theories were preserved in present theories, some theoretical assumptions of present theories will also be preserved in future theories. There is no evidence that the pessimistic induction and the selective induction have an impact on scientific practice. Suppose the scientists refuse to entertain an alternative to a current theory as a result of embracing the pessimistic induction. Or suppose the scientists make a conscious effort to preserve success-fueling components of a current theory when they formulate an alternative to it. If such events occur in science, we can conclude that the pessimistic induction and the selective induction have an impact on scientific practice. Unfortunately, pessimists and selective realists have not yet provided the case studies of such episodes. The pessimistic induction and the selective induction shouldn't make any difference to scientific practice. There are historical episodes in which successive theories didn't share theoretical assumptions. For example, pre-Socratics, the initiators of science, proposed various theories about the fundamental building blocks of the universe. To put briefly, Thales claimed that water was the basic stuff, Anaximander the boundless, Anaximenes air, Empedocles earth, air, fire, and water, Anaxagoras infinitely many things, Heraclitus fire, Parmenides the one, Pythagoras numbers, Democritus atoms. These philosophers' successive theories didn't have any common theoretical assumption. If Democritus had been a pessimist or a selective realist, he would have thought that a new theory to be developed would be discarded in toto. As a result, he wouldn't have bothered to develop atomism. It doesn't follow, however, that the pessimistic induction and the selective induction are worthless. Poems, sports, music, and art are valuable, although they don't make any contribution to science. Similarly, the pessimistic induction and the selective induction are valuable, although they don't make any contribution to science. They have intrinsic value to philosophers and scientists who wonder whether we can infer the fate of present theories from that of past theories. Pessimists claim that realism has a negative implication for scientific policy. On their account, if scientists and scientific policymakers embraced realism, they would be conservative and they would not support the research proposals that aim to develop alternatives to existing theories. In response, I invite pessimists to imagine what would happen if scientists and funding agencies embraced the counter-induction for realism that I enunciated in Chapter 4. Scientists and funding agencies would happily support the development of alternatives to existing theories. After all, they don't believe that existing theories are definitely true, but rather likely to be true. Moreover, the downfall of existing theories would constitute second-order evidence for alternatives, and thus alternatives would be more likely to be true than existing theories. Therefore, scientists and funding agencies would support the advent of new theories. The argument from undiscovered evidence, which I expounded in Chapter 4, also has a favorable implication for scientific practice. The argument says that since a theory has been supported by previously undiscovered evidence, it will continue to be supported by hitherto undiscovered evidence. If scientists endorsed this argument, they would be motivated to perform new experiments to support an existing theory. The argument from neighboring theories, which I unfolded in Chapter 4, also has a positive implication for scientific practice. The argument says that since the theory has been supported by previously unconceived neighboring theories, it will continue to be supported by hitherto unconceived neighboring theories. The argument encourages scientists to pioneer new neighboring fields of science and to develop new neighboring theories. If funding agencies embraced the pessimistic induction, they would disapprove of research proposals, whether research proposals aim to build upon existing theories or to build upon alternatives to them. After all, the pessimistic induction implies that to build upon existing theories is to build upon false and empirically inadequate theories, and to develop alternatives to them is to develop another false and empirically inadequate theories. As a result, funding agencies would not support research proposals. If scientists embraced the pessimistic induction, they wouldn't bother to develop new theories, and they would become listless and lethargic cognitive agents because they would think that new theories will turn out to be false and empirically inadequate. Therefore, the pessimistic induction shouldn't have any impact on science. Let me raise an interesting question. Who would be more supportive of scientific revolutions, realists or instrumentalists? Suppose realists and instrumentalists believe that existing theories are true and empirically adequate, respectively, and the scientific revolutions occur. Realists would lose their old beliefs that the existing theories are true and form new beliefs that alternatives are true. As a result, they would get closer to truth. By contrast, instrumentalists would lose their old beliefs that existing theories are empirically adequate and form new beliefs that alternatives are empirically adequate. As a result, they would get closer to empirical adequacies. In short, realists lose a lot but gain a lot, whereas instrumentalists lose a little but gain a little from scientific revolutions. Therefore, it is not clear who would be more supportive of scientific revolutions. It is wrong to think that instrumentalists would be more supportive of scientific revolutions. According to surrealism, observables operate as if a theory were true. Surrealists suggest that a theory is successful because observables behave as if it were true. Surrealism invokes the behavioral pattern of observables to explain the success of a theory. If surrealism permeated scientists' minds, it would have a negative impact on scientific practice. Imagine that you are a scientist. You worked hard to develop a new theory, and your theory shows an impressive performance, i.e., it makes true predictions. However, your fellow scientists come along and say, your theory is successful not because you were creative, but because observables behave as if it were true. Such an explanation would depress you. Consequently, surrealism would have a negative psychological impact on scientists. Non-committalism is the position that is not committed to any claim. Anti-realists tend to retreat to non-committalism when the position that a theory is empirically adequate is under fire. If scientists embraced non-committalism, they would become listless and lethargic cognitive agents, not even bothering to conceive of hypotheses. After all, they would be non-committal about their own hypotheses, and their fellow scientists would also be non-committal about their hypotheses. Where there is no incentive, there is no science. Let me now suggest some feasible ways for realists and anti-realists to contribute to science. First, come up with the case studies of present theories, not past theories. Participants in the realism debate have been presenting the case studies of past theories, especially physical theories of the 19th century, to take an epistemic attitude toward present theories. In my view, however, taking an epistemic attitude toward present theories requires not the case studies of past theories, but rather the case studies of present theories. As realists and anti-realists dig into the current scientific literature to come up with the case studies of present theories, they might hit upon new scientific hypotheses. Second, teach philosophy of science courses to science majors. Third, publish papers or books accessible to scientists. Keep in mind, however, the value of philosophy of science doesn't lie in its contribution to science, any more than the value of science lies in its contribution to philosophy of science. I just summarized chapter 10 of my book, Embracing Scientific Realism. Thank you for watching. See you next time. Bye.